What's good, my analysts? And today I want to talk to you about scheduled tasks. So I was going back and looking at incident data again, and just like last year, I saw that scheduled tasks continue to be leveraged by adversaries and malware in the vast majority of incidents that we respond to. Looking at a lot of the data, you can see that a scheduled task and a malicious scheduled task has been used prior to the adversary completing their objective in over 80% of all incidents that we had investigated. So I wanted to make this video to go over a little bit about scheduled tasks. Now, I'm not going to do a deep dive on how scheduled tasks work or anything like that, because honestly, you can just Google it. It's pretty easy to understand. But what I do want to do is I'm going to go over some high level, quick wins on analyzing scheduled task data, because based on what we've seen in our incidents and what I know to be happening across various different attacks, is that if organizations did nothing else but get extremely good at detecting and responding to malicious scheduled tasks, there would be a massive reduction in successful cyber attacks. And so what I want to do is kind of just share some information and walk you through, like I would say, the first 5 or 6 things that I always do when I'm looking at scheduled task data to find the evil. And then hopefully we can move the needle and make the adversaries burn some intellectual capital instead of just leveraging scheduled tasks all the time. Fun fact is I actually found that some pretty awesome malware that bypassed a lot of the security tooling out there. And the only reason that we came across it because of just looking at scheduled task data as a whole and identifying it as an anomaly and being like, what does this scheduled task do? And then you find like, oh, this is like crazy advanced malware, but they're still leaning on a scheduled task, which is great for us, for our defenders' point of view, because now we have a logical choke point based on data to say that, more than likely they're going to use a scheduled task at some point, and if we can get them there, then it doesn't matter all the fancy whiz bang tools, because they're still going to rely on the scheduled task because it works exceedingly well. So we're going to run through it right now. The first thing you need to know, like Google scheduled tasks. If you don't know what that is, I'm not going to run through it. Basically, that's a thing in Windows in which you're able to say, hey, when these conditions are met, do this thing. And that thing can be a bunch of different things. Run a program, do kinds of different things. If you're not familiar with it at all, I suggest just Googling it, but that's generally what it is. Now, over time, Microsoft has kind of changed how tasks are run. So they've always been kind of run through something called the task scheduler service. So it does run as a service, although the scheduled tasks do not run as a service, right? So the way that this actually works is that there is a scheduled task service that runs as a child to service host in the net services service group. And the way that kind of manifests, if you're looking at real-time data, depends to be different depending on what flavor of Windows that you are looking at. And this is like, hey, first things first, you recognize what kind of data you have or what kind of systems you have in your fleet. And so like how am I going to find scheduled task data if I'm not using something like auto runs or scripting out and pulling back all of that data. So in Windows 10 here, we can see that the scheduled tasks are the parent of it. So I just ran calculator as a service, and you can see it runs, as I said, as a child to service host in the net services service group, and then they specifically call out schedule. So if you're looking at EDR data, if you're looking at 4688s or Sysmon or something, you can say, show me everything that is a child of this command line, parent command line, if you have that data available, and you're going to see everything that's been run as a scheduled task. Now, in Windows 8 and 8.1, the parent is just registered as service host as part of the net services service group. So that's going to get things a little bit tricky, because that's going to be a little bit more messy. There's a lot of things that run as a child to that one. So you're going to have to do some analysis that way to figure it out. And there's some other ways that you can contextually figure out what is a scheduled task. But you need to know, if you only have parent-child relationships, you only have process data, you're going to have to know that, okay, I got to look for children of service hosts that are launched as a child of the net services service group, and there may be scheduled tasks in there. There may be other things in there, and I'm going to have to learn how to filter that kind of stuff out. In Windows 7, they actually changed it. So there was a process called taskeng. So it is the task running engine, and it ran all scheduled tasks, which is nice because that kind of stands out. It gives you a single point to go into to say every child of taskeng is going to be a scheduled task, and the parent of taskeng is service host -k net services. Oh, I think I have a Windows XP machine, and I'm pretty sure it's just net services. So if we run calculator here, I don't have sysmon on here, but your boy's still got some skills from back in the day. 1872, remember that? 1872, and we should be able to do get parent P. It's 804, and then 4, and then we do get command line, and we should be able to see what that is. And then we can see, okay, yeah, we have a parent process, just the net services service group as part of service host. So you need to know that. If you have XP machines, Windows 7, 8, or Windows 10, you're going to need to know that that's the parent if you're talking about real-time data. We're going to do some examples based on auto runs data, just because it's the easiest to kind of, it does a lot of the data fusion together, and it's going to allow me to quickly kind of work through this. If you don't have that data, you can either go out and grab it. You know, some people go out there and just grab the XML files. That's it. Oh, another point is that, you know, scheduled task data is actually written in as XML data in system32/tasks. And there's a whole file hierarchy, and each scheduled task is in an XML, and in there's things like, say, like the name and what actions you should take and the conditions that match up with that. So you can also collect that data, parse it, and enumerate it, and get all kind of scheduled tasks within an environment. Or you can just run auto runs or anything you'd like to do. Okay, so now that we know a little bit about scheduled tasks and how they kind of operate, let's take a look at some quick wins on how to analyze this data to try to find some evil. Okay, so the first thing that the theme of everything I'm going to be talking about here is that you know, not only are we going to look at data, is that we should actually try to apply some context behind our analysis. Meaning, we should think about how is a scheduled task used by an adversary, and then what circle of data can we operate in to push our analysis into a very specific vein to help our brains, you know, if you have a person looking at this, to help them look for a very particular thing within a data set that is, you know, the data set we're going to look at is not going to change. The only thing that's going to change is the context in which we apply our analysis, if that makes some sense. So the first thing here, you know, classic frequency analysis, we're going to do stack counting on the file path. And we can just say, look for anomalies in there. The first one right out of the bat, we see mimikatz is right there, right? Okay, so why is that? You know, hopefully, when you look at your enterprise's scheduled task data, you're not going to have a lot of mimikatz running as a scheduled task. So that should stick out like an anomaly. Now, one thing I will say about stacking by file path, it is great, and you will find stuff that way. But as your data set grows, it gets a little bit cumbersome, and it gets harder for your analyst to be effective. So what I would recommend is if we apply context to what we're actually looking for, is to say, if I'm stacking by file path, then what I'm actually saying is I'm actually looking for the event that the adversary or malware had introduced something new to the file system. So what I can do is fuse that, if you have it available to you, with enrichment data or, you know, baseline data. And what I mean by that is to say, if I have enrichment data, to say, okay, I only want to stack on file path on binaries that I know aren't signed by Microsoft or don't come back clean from whatever, you know, hash checking enrichment engine that I'm using. So if you're using VirusTotal or Versing Labs or whatever that is, you say, okay, I want to do a join search, and this is kind of what I do if I'm looking at file paths. Join my search to say, show me any hot hash that comes back as unknown or malicious or suspicious of those then do stack on file path. So then I can eliminate all the stuff that we know to be good, and kind of just say, okay, the context of my search here is that the adversary had introduced something new into the environment, and that's what I'm going to be looking for. They're probably not going to introduce a legit Windows binary in some one case, but I know what you're thinking of. You're already, if you can, I mean, the dozens of people that are going to see this, but you're going to say in the comments, but wait, I'm going to get to that. But in the context of this, I'm saying my analysis saying they introduced something new. What is the best way for me to find that is actually eliminate the stuff that we know to be good and know to be default on the system. So get rid of like the things you know you're going to see, like the PowerShells and the run DLLs and the commands that happen by default. And all the normal system 32 bins or whatever that are in there all the time. We can eliminate those because we know to be good based on our enrichment and only look at things that wouldn't be normal. So that's number one, is stacking by image or stacking by file path, but then also joining that with some enrichment to say, oh, show me only things that we know not to be legit. And I'm only going to look at stuff that has been introduced afterwards. Obviously, you're going to do some keyword searches on that too, to look for things like TeamViewer and any kind of the remote utilities. Do that as well. Just say, show me all the TeamViewers and the PS execs and those kind of things as well, because we know that adversaries use those. But that's a keyword search, or you can use enrichment to look to see what it's signed by as well. Okay. And again, this is an exhaustive list, so don't at me and say, well, you forgot about this particular way. This is just like the first 5 things that you should do, low-hanging fruit. Okay, so the opposite way of that is to say, okay, since we're not looking at file path, what's a different contextual way to do this? And probably the most popular way scheduled tasks are used is to say that command interpreters are used to run some sort of malicious command which does something. The encoded PowerShell blob is the most famous one that you run into, is that you would see PowerShell dash command or dash encoded command and then a bunch of Klingon, and that does something evil like that. So the context behind that is like, I don't really care about the file path, because in our search, we know that the file path is going to be legit. The only thing that I really care about is the command line. So I'm going to be doing frequency analysis on command line, and I can even further kind of enrich this to say, I'm looking for command lines that I know to be suspect. So I can build out, the living off the land encyclopedias out there. You can know the context between, hey, how is normally PowerShell used from more malicious ways? Let me say, show me all these launch strings that have these keywords in that, do analysis on that as you grow in your data set, where it's going to be harder and harder to do kind of frequency analysis. But just doing this as well will be enough where you'll start to see that the anomalies in this one. In our little tiny data set here, it's pretty easy to go through. Here we can see, I just took like the heavy hitters. I know that there's more than this on a Windows system, but these are the most common ones where I'm saying, show me all scheduled tasks associated with PowerShell, CMD, Run DLL, Reg Server, and WMIC, and then just let me look at the context behind this is what would be the interesting piece, the command line parameter. And then you will find evil just doing those 2 things that I talk about. You will find stuff, I'm telling you. Find it all the time. All right, the next thing we're going to talk about here is to say, okay, along that same path is to say, okay, well, now I'm actually just going to look for script files. We know that that is used a lot. Now, we're not going to see something stand out as anomalous from a command point of view, except for maybe a file path, right? But we're going to kind of separate that contextually to say, I'm not looking for a malicious command. I'm looking for a file path in the command line that is suspicious. And in this case, we're saying, show me like all of the standard Microsoft scripting file extensions, and we're going to do frequency analysis on the command line there. And we can sort that and we see, okay, automatically this one bubbles up to the top, a batch file sitting in system apps, something in temp. This is probably legit. I run across that all the time when you find like custom PowerShell scripts that are running. It's just admins doing their things, and they're going to be in some tool. Scripting in startup programs, boom, easy one. This one is very interesting if we can go on a tangent for a second. So that VB script, you'll find that a lot. If you look at a lot of enterprise data and you're looking at different various Windows kind of distributions out there, and depending on how they're built or where they're built, you're going to see a scheduled task associated with get network info.vbs. And the other one that you'll come across with is kerncap.vbs, and kerncap.vbs is kind of interesting because that one is actually associated with a WMI consumer by default in some cases. And I've never seen it happen yet, but I'm wondering at some point whenever adversaries are going to start hijacking either that WMI consumer or the associated scripting file, because you see it so often, you kind of just go through it, but there's nothing stopping someone from just updating either the consumer or changing the content of that script file and using it to execute something malicious. So keep that one in the back of your brain, as, yeah, okay, you're going to run across that a lot, but you might want to do your due diligence to see exactly what those script files are doing, because they could be very easily hijacked to do something sus. But anyways, in this case, we're saying, look for suspicious script files in specific, in weird locations. But in that case, you're actually going to be looking at the command line. Now, another thing you can do in terms of script files, and this will catch evil stuff all the time, is if you say, okay, well, show me like all scheduled tasks associated with W script or C script, and the command line doesn't contain a .vbs or .js or what are any of the common scripting extensions. We see that all the time with malware, is that you'll see like wscript.exe/b jscript saying, okay, denote this script file as jscript, and then the path will be to a text file. Clear indicator that that's something evil. You're going to run, if you see that, I'm willing to bet, take the Pepsi challenge on that one, that it's probably some sort of malware. But that's another good contextual one too, to say, oh, yep, it's calling a script interpreter, but actually not calling a script file. That's something we can key in off of that we know that adversaries are doing. Moving on. Okay, so the next thing we're going to do is we've already kind of looked for when things are introduced new to the system, but also this is very popular as well, in which case the adversary will actually leverage binaries that exist on the system and move them to a different location, or rename my malware calc.exe and put it somewhere else. That happens all the time, right? And so even if it's a legit Microsoft binary, Dridex is famous for doing this. And, we've seen DLL sideloading become more and more popular over the last 3 years, in which case, okay, contextually, here is my thought, is we know that there's malware out there that's using DLL sideloading. What's a really easy way to identify evidence of that is, like, if I know that, give me all of the standard binaries that exist in Windows, especially like the most common one, and that's the example that we're using with, is a binary that by default lives in system32. And if I find a scheduled task that's associated with one of those binaries where the path to that binary is not system32, I want to bubble that up to the top for analysis. So, and that's the context behind this, and we know that that maps directly to an adversary operation, and so it provides like a really good way. And this has a low false positive rate, and you can do this for a lot of different things. And if you're really good, if you got your stuff really buttoned up, like with application whitelisting, this is a home run of a search, because you should have a pretty dead set list of binaries, and bypassing one of those ways is to do DLL sideloading if we're just doing application whitelisting on executables. So we run this, we can see we get a hit, right? So CMSTP, that lives in system32 by default, but this one is actually in the user profile. If I dig into that even further, I'll find that that's actually a Dridex infection. That's a real one. That happens all the time, and that's a really good one. You should do that one every single time, and you can expand that out to syswow and to see windows and program files, and do the kind of same thing with a lookup table. Okay, getting a little fancier now. The one thing you can do is actually do something. Wait, no, that's not the one I want to do. Again, we do this live every time. We're not moving on to that one yet. We'll do this one. Okay, so famous, for as long as malware has been malware developers have been lazy. That's just a fact, right? Is that, single character or double character executables associated with a scheduled task often tends to be malware, right? So looking for, in this case, I'm going to say contextually, show me all scheduled tasks in which the file name is, you know, 2 or less characters, right? And if I look at that, then it's a really easy way to take a bunch of data, prune it down to a particular mindset and context, and get something out of that one. In this case, neither one of these are malware, although this m.exe, I probably want to check the hash on that one since there's only one across my data set. I can't remember if I actually made that one malware or not. But in this case, it doesn't really matter. But that's an easy way to say, okay, evaluate that file name, show me everything that's less than a 3-character file name, and let me take a quick triage on that, looking for suspicious paths along with a single character thing. So I mean, like, you know, things in user land, like in a user profile or program data or temp directories, C tool, C intel, and it's a single character. Those two kind of characteristics would be something that you wanted to triage. Okay, finally, we can get a little bit more fancy now. So entropy, which my buddy Jeremy loves so much, is another way you can analyze that. And there's the famous kind of algorithm that I've used the most, and there's other ones out there, is Shannon entropy. It's basically a calculation of the randomness within whatever data set that you're looking at. In this case, we're looking at the name of the entry. So in the name of the task. A lot of times you'll run across random character task names or single character task names that are often associated with malware, even if the binary is named whatever, legit binary. But the name of the task, a lot of malware just randomly generates that. And so you'll see, you know, gobbledygook as a name or a single character. And in this case, we can measure, you know, it's not a great data set for it, to be honest with you, but I'll show you an example of it. And so we can either look at min or maxes, right? A minimum, like like a score of 0 in entropy is probably going to be like a single character thing, which is suspect, or, you know, because every one's the same. That's not going to have much entropy. And that's going to be an anomaly. Or maximum or high values of an anomaly of entropy will show a bunch of randomness in there, right? And so that's the way to do that. On entry name, it's not as great as it is for file names, especially across a data set that is known, but it's an example, right? And you can apply different algorithms that you want to it. If we look at this one, it's going to run and say, okay, well, show me a 0 because I know that one's in there, and we can see X or yeet in there is in the min side, and I'm going to triage ones. Especially, like, you can take these two things together to say, okay, not only is the entry name have a low amount of entropy, but it also is pointing to like the desktop or user profile. And those two pieces together would be like, yep, we're going to tag this one to be investigated further, or I'm going to triage this one even further. But that's a way that you can also use entropy and file names or entry names or paths or something along those lines to get, you know, another thread to pull on. Okay, now finally, I want to touch on this one more of like, yeah, you got to be aware of this. So if you look at enough scheduled task data, you'll see that some scheduled tasks are associated with, in Windows, it'll say like a custom trigger. And if you pop that thing open, pop open the XML data, you'll see that it actually is referencing a class ID. So you can actually load a COM object as a scheduled task within Windows. And not as common as any of the other ones we've seen before, but I have run across it where, you know, either hijacking a COM object or introducing a new one, registering that as a scheduled task, is a way to hide in it. Now, auto runs does a good job of actually doing the legwork for you, but if you don't have that, what you will see is that there is, again, depending on the flavor of Windows, you will see that there's another binary called taskhost.exe, taskhostw.exe, taskhostwx.exe. I believe it's taskhostwx in Windows 8, and it's taskhostw in Windows 10 now. Google it, it's out there. But you'll see that that is a child of service host as well. And what that process is responsible for is loading libraries that are associated with a scheduled task. And you will see taskhost.exe, and then as a parameter, the class ID. And the class ID will be what is written in the XML data, and Windows will go through the registry and show you the associated DLL. And that's what you can see through in the auto runs data here. It kind of does that automatically for you. As you can see that the action and the XML data for this task is this class ID. And so Windows will go through, classes root or software classes, go down, find the class ID, whatever's in proc server is a path to a DLL, it'll load that. And in the real-time data, unless things have changed, you will be able to find that that task host process is loading that module on behalf of the task. So you might want to take a look at DLLs or other libraries that are being loaded by those additional ones to find even more stuff. Now, it's not as common, but it is a thing, right? If you're collecting auto runs data at scale, it does that hardware for you, and then you can go ahead and kind of do the same thing. You're going to get a path. It does a good job of populating the path from the registry. But if you're just looking at EDR or sysmon data, you're not going to have that as well. So you got to kind of look at that, what it's loading and what it's doing, or the arguments that are being loaded on those things. So that's all I had for you. I know that there's a lot more to task data analysis, but those are like really high level quick wins that are really effective over the years that I've been looking at data. Those things, if you did those things and got like really good at doing all of those things, you would probably catch a lot of evil out there. So I hope that helps. As always, happy hunting, and I will see you next time.